show that u1 and u2, this set is an orthogonal basis for R2. So how do we check if it is a basis for R2? So R2 means dimension of R2 is 2. So we need two vectors, and for basis we need linearly independent vectors. So as soon as we find two linearly independent vectors in R2, then they form a basis. And orthogonal means their inner product, okay, u1 and u2, their inner product, which is same as dot product, it should be 0, number 0. Okay, let's check that. So we got here u1 and u2. After we show that, then express vector x, which is given here, as a linear combination of u's. So we got u1 and u2. Okay, so we got two vectors, u1 and u2 are linearly independent. Why? Because one is not a constant multiple of other, because if we multiply this by some number, we can never get this, because one vector, one is not a multiple of the other. So linearly independent, and how many vectors we got here? Two vectors. So two linearly independent. Okay, so this implies u1, u2 is a basis. But we need to show orthogonal basis. So next, let's find the inner product, which is dot product of u1 and u2. So u1 is just 3, 1. u2 is negative 2, 6. When we multiply, when we take this inner product, we just multiply the components. 3 times 2, negative 6, plus 1 times 6, 6. So 0. That means these two are orthogonal to each other, and they are already vectors for basis. So this implies u1, u2 is an orthogonal basis. Okay. Now the next part is we need to express x as a linear combination of u's. So u1 and u2. So for what we do is let x is a linear combination, so plus some unknown constant c1 u1 plus unknown constant c2 u2. Okay, that is in terms of numbers. Our x is given negative 6, 3 equals c1 to be determined, u1 is given 3, 1 plus c2 to be determined, u2 is negative 2, 6. Okay, now we want to solve this system. Okay, so this is same as, now you can write in terms, you can write augmented matrix. Okay, let me go that way, or we can form a system of two linear equations and solve for c1 and c2. So this is in terms of augmented matrix. We just write these first because this one is right hand side. 3, 1, negative 2, 6, negative 6, 3. Let's make this 0. Okay, with row reduction. Or we can swap R1 and R2. This is same as row 1. Let me write 1, 6, 3, 3, negative 2, negative 6. Now next we keep row 1 and multiply row 1 by negative 3 and add with this. Okay, so multiply by negative 3 and 3 0. Negative 3 times 6 negative 18. Negative 18 plus negative 2 negative 20. So negative 3 times 3 negative 9 plus negative 6 negative 15. Now from this is C1 C2. We could have written x1 x2 or any other variables. So this one C1 C2, here is a pivot. This implies negative 20 C2 equals negative 15, or C2 is divided by negative 15, negative cancel, negative 20, divided by negative 20, negative cancel, so 3/4. That's from the second row. Now from the first row we got C1 plus 6C2 equals 3, or C1 is just C1, 6 times C2 is 3/4. That is, now we can find C1 equals, so 2 3, so 9 halves. 3 minus 9 halves, 3 minus 9 halves is minus 3 halves. This is minus 3 halves, and there is a 3, 3 minus 9 halves is negative 3 halves. So thus x is C1, which is negative 3 halves U1, plus C2 is 3/4 U2. Okay, final.